All right. How do I do the first one? It's always the first thing you do when you factor. Greatest common factor. What is it? 2. 2. What's 128 divided by 2? What's that called? Perfect squares, right? Difference of squares. So when you see two perfect squares and a minus, you make two sets of parentheses. What's the square root of x squared? What's the square root of 64? Then what? Plus and a minus. Okay? Doesn't matter if you go minus plus or plus minus. Just one of each. Right, Connor? What about number 2? What do we do? There's GCF. No. It's not one of these because it's got 3 terms, right? Is this both positive perfect squares? No, it's not one of those special ones, right? So it's a regular trinomial. Someone already said, what do you got to do with 2 and 2? Multiply them, right? We get 4. What are the factors of 4 that add up to negative 5? Negative 1 and negative 4, right? So I rewrite it. When a is 2 or bigger, you rewrite it with 4 terms. You change the negative 5x to negative 1x minus 4x, or minus 1x minus 4x. The first and the third term don't change, okay? So you just split the 5 up into those 2 terms. And then we do what, since it's got 4 terms? Group them, right? Since this third term had a minus in front of it, put it inside the group. All right, take out GCFs. What's the GCF of the first group? X. What's left? 2x minus 1, right? Since there's a negative there, pull out the negative sign. What goes into those 2? 2, right? Negative 4x divided by negative 2 is positive 2x. Positive 2 divided by negative 2 is negative 1. Is it working out like we want? Yeah. So one of my factors is 2x minus 1. When those are the same, that's one of them. And then the GCFs you pulled out is the other. Okay? So those are similar to the first 3. We hadn't done factoring for a while, so I wanted to practice a couple more. Okay? Some of you were struggling a little bit when you started yesterday, this practice quiz. So number 1, is there a GCF? Yes. What is it? Come on, let's pay attention. So we divide 5 into all 3 of those and get x squared plus 4x minus 21. Okay? This has got 3 terms. It's a trinomial. Is that a positive perfect square, that negative 21? No, so it's a regular trinomial, right? What's the a value of this trinomial? No. 1. The number in front of the x squared is the a value, right? So there's a 1 in front. Do I need to do like I did this one on the right? No, I don't need to do that because a is 1, right? It's a lot quicker. It's an easy one. I just bring the 5 down. The only way to get x squared is what times what? X times x, right? So it's got to be those 2 for the front. What are the factors of negative 21 that add up to 4? Positive 7 and negative 3, right? You don't have to rewrite it and make it 4 terms like some of you were trying to do, right? It's okay if you do. You just make it more work, though. Okay? Those are what work. So it's just plus 7 and minus 3. And we've got it factored. Okay? It's when that a is 2 or bigger that I have to make it into the 4 terms, a grouping.
I did that slightly different. So like I found like the GCF of 5,
right?
and then I did like I found like and got like the 7 and the -3, but I didn't have like the 5 and 5.
Mm-hmm.
I just divided it. How many points did you pick off of that?
Probably just a point, because you took it out at first, right? You just
Yeah.
forgot to put it in your answer.
Yeah.
Yeah. Okay, just remember that 5, that GCF you pull out is part of your answer when you're done. All right, number 2, is there a GCF? No. It's got 2 terms. Are they both perfect squares? Yeah, any even exponent for a variable is a perfect square, right? And is there minus between them? Yeah. Okay, so it's one of those difference of squares. So you make 2 sets of parentheses and take the square root of x to the 6th, which is x to the 3rd. You just divide the exponent by 2 when you take the square root of an even exponent. What's the square root of 100? 10. And then 1's addition, and 1's subtraction. Okay? And there's nothing else we can go further. Okay? So we factored it completely. Number 3, again, I always ask myself if there's a GCF. Is there a number that goes into all 3 of those? No. So it's 3 terms, and they're not both positive perfect squares, so it's one of those regular trinomials, but a is 6 this time. So I have to multiply 6 times -5 and get -30. Now I'm looking for factors of -30 that add up to -13. All right? A lot of you are thinking 10 and 3. All right? But if I go -10 times a +3 to get -30, when I add those, I get -7. If I go +10 and -3 to get -30, I get +7 when I add them. So a lot of you are stuck on that. But actually what works is a -15 and a +2. I get -30 when I multiply them, and then when I add them, I get that -13. So this is one that you have to rewrite. And it doesn't matter if you put -15 plus 2x or plus 2x minus 15. It doesn't matter what order you put those 2 in the middle. Just so it's a -15x and a +2x. And then we group them like we did that warm-up problem. What's the GCF of the first group? 3x. 6x squared divided by 3x is 2x. -15x divided by 3x is a -5. What's common to the second group? Nothing, but we can't put nothing. We have to put the number 1, because 1's common to everything. So that's where some kids will make a mistake. They'll forget to put a 1 there. And dividing everything by 1 is itself, right? So 2x minus 5 showed up in both of those. So 2x minus 5 is one of my factors. And then there's GCFs, 3x and 1 become my other factor. Questions on 1, 2, 3, the factoring? Okay. 4, 5, and 6 was simplifying radicals. So this is when we look for a factor tree. (36) I circled because it's a perfect square. So what number will come out when I take the square root of 36? 6. Some of us are taking out that, like actually 36 out. George.
I did 9 and 8.
That's okay.
Okay.
And then 8 becomes 4 times 2, right?
Yeah.
Right. So for the 9, you take a 3 out, and for the 4, you take a 2 out. What's 3 times 2? Right, so we still pull 6 out, right? So it doesn't matter how you start. You'll still pull out 6. All right? When I pull that 6 out, whatever's already here, I multiply by. So I gotta go 4 times 6 and get 24. Because this is here, what else do I pull out? The I, that imaginary unit. And then what's left under the radical sign is that 2. Okay? So don't forget about that part. Questions? Okay, number 5, we have a fraction. Can we reduce that fraction as it is? No. But if there was a number that went into both of those numbers, I'd reduce it, make it smaller. Okay? So we're thinking like this. Are we allowed to have that radical in the bottom? No. So what we do is we call it rationalizing the denominator. And what we do is we multiply the top, the numerator, and the bottom, the denominator, by that square root of 7. Okay? The square root of 5 times the square root of 7 is the square root of 35. The square root of 7 times the square root of 7 is the square root of 49. But what is the square root of 49? 7. You don't have to, I mean, if you want to just put 7 right away, that's okay. I was just showing all the work. Now it's simplified. No radical in the bottom. I can't simplify the 35. Number 6, I need to simplify that square root of 18. So I did a 9 times 2 factoring. 6 times 3 is okay. You just got to break the 6 down into 3 times 2. So you have 2 3s. 2 3s or the square root of 9 makes you pull out a what? A 3, right? So if you got 2 of the same number, that's like a perfect square in there, right? If you did it that way, or again, I try to figure out, I think about 4s and 9s and 16s and 25s when I do my factor tree, because I'm looking for perfect squares. Okay, sometimes you find them, sometimes you don't. So I pull that 3 out because of the 9, and I have this. Is that fraction reduced all the way? In simplest form? No. Look at the numbers that are not under the radical sign. Is there a number that goes into all 3 of those? 3. Yeah.
I was thinking of that.
Okay. So I divide 3 into all of those. So 3 divided by 3 is 1. And 3 divided by 3 is 1. You can put the 1 like I'm doing, or you don't have to, in front of the radical. And 6 divided by 3 is 2. So there's our final answer for that in simplest form. Okay? We simplified completely. Questions on the radicals? Again, tomorrow it's going to be 3 factoring problems to start and 3 radicals. Okay? And then we'll start solving our equations. Okay? So number 7, since there's no b value, my a is 3, and my c, actually I don't have it equal to 0, so my c is not 4, but since there's no b value, I don't have to set it equal to 0. I can just get the x squared alone. And I tell you that, it says solve by using square roots, right? You don't have to factor this one. Just subtract the 4. And divide by 3. Again, we're trying to get the x squared isolated or alone. Now it's alone. Now what do we do to turn it into an x? Square root both sides, right? And remember, when you do this step, your answer needs a plus or minus in front of it, right? So that's x, the square root of x squared gives us that x, what we're looking for. And then we're just simplifying the radicals like we just got done doing. What's the square root of 4? 2. So the 2 comes out front, and the 3 is left. Okay? Every now and then I get kids that switch those, put the 3 out front and leave the 2 underneath, right? One that's the perfect square, whatever the perfect, the square root of that perfect square is, that's the number that goes out front. Okay? No. Correct. Now everybody else is here. You're welcome. Bye. All right, number 8. This says solve by factoring. All right, we got a x squared, an a value of 1, an x, a b value of 4, and a c value over on the other side. Okay, so if we have to solve by factoring, we want to set it equal to 0 to start. So I have to subtract the 45 over. So here's what we have. So to factor this, is it a GCF? Or is there a GCF? No. So it's got 3 terms. Is it a special trinomial? The first term's a positive perfect square, but is the third term a positive perfect square? No, it's not, right? So it's a regular trinomial. A is 1, so all I have to worry about are the factors of negative 45. What 2 factors do I want that will add up to positive 4? Right, 9 and negative 5. So plus 9 minus 5. Now, the first 3 didn't have us equal to 0. We didn't have to go further once it's factored. This one's equal to 0. I have to finish it up. I have to figure out what values of x makes this work, right? Makes it equal to 0. All right, so what I do is I set each factor equal to 0 and solve for x. So one of my answers is positive 5. And my other answer is negative 9. Okay, so make sure you finish when you're solving it. Okay, if I go to the original problem, what's negative 9 times negative 9? Positive 81. What's 4 times negative 9? Negative 36. What's 81 minus 36? 45, right? What's 5 squared? 25. What's 4 times 5? 20. What's 25 plus 20? 45. They both work, right? That's what we're doing. We're solving. We're finding what values of x make it a true statement. Questions on the first front? We better? Some of you struggled with the front because it's been longer since we did these. All right. Tomorrow they're going to look any different? No. Not going to look any different. Right? Same type of problem. Okay? So practice tonight. Number 9. We're subtracting one complex number from another complex number. Okay, so all we're doing is combining like terms. So what's 3 minus 8? Negative 5. What's negative 6i minus 5i? Negative 11i. Okay? Where you guys might get tripped up is when there's a minus inside the parentheses, then you've got minus a negative. You got to turn it into addition, right? So just combine like terms. Number 10. All we're doing is distributing, right? So you go 3i times 7, and 3i times negative 2i is negative 6i squared. Okay, so remember, we have learned in these couple sections of this chapter that I squared equals what? Negative 1, right? So this is like negative 6 times negative 1, which is positive 6, right? So what I like to do is just cross that out and change the sign. All right? So if you leave it as 21i plus 6, that's okay. The proper way to write this, though, is 6 plus 21i. That's the right order. But I'm not going to mark it wrong if you don't put it in the right order. But we should understand that. You okay with 10? All right, 11, we're multiplying two complex numbers, so we're foiling. Again, some people will do number 9 like this. They'll try to do number 9 by foiling. What's the difference between 9 and 11? Yeah, it's subtraction. Or it might have an addition sign tomorrow. All right, number 9. So just combine like terms. Don't try to foil if it's not multiplication. Okay? This is multiplication. There's no symbol between the two parentheses. So that means multiplication. So we're going to foil. So first, 5 times 6. Outside, 5 times 2i. Inside, negative 3i times 6. I want you guys to pay attention. Last, negative 3i times positive 2i is a negative 6i squared. All right, so we have that I squared again. Okay, so I'm going to turn it into plus 6 because it's negative 6 times negative 1. Now combine like terms to finish. 30 plus 6 is 36, and 10i minus 18i is negative 8i. Alright, so we're foiling number 10 or number 11. Number 12 is just like number 11, but it's a little quicker. It says multiply the complex number, 6 plus 3i, by its conjugate. Emma, what's the conjugate of 6 plus 3i? 6 minus 3i. So change the sign in between the two numbers, between the real part and the imaginary part. Okay, you can foil it, but you don't have to. Okay, if you foil it, the outside part and the inside part are going to be negative 18 and a positive 18i. What happens to them? They cancel. So what I've told you is take the a part, remember, complex number a plus bi, the real part, and square them, and the imaginary part, and square it. Don't worry about the I, because the I is going to go away. All right, so that's 36 plus 9. So that's 45, our answer. Okay, if you forget that little shortcut, you can just foil it, you'll get the same thing. Questions on 12?
Do we need to write out the 6 plus the y, or the 6 minus the y, we're just gonna do it?
I guess you wouldn't have to, would you? Yeah, you're gonna write 6 squared plus 3 squared, right? Okay. I guess that'd be okay. And then 13, the last one, we're just getting, it's basic. It's just like number 7, right? Except what kind of radical do we get? What are we gonna do? To start, subtract the 2, right? So that's a negative 20, and then we're going to take the square root and simplify our radical. So Mason, what do we get when we simplify it?
X squared equals, we're gonna split off the 4 and the 5 and 4 is the square root. Perfect square, sorry. So you're gonna put 2 on the outside.
2, okay, anything else?
5 is the negative, and then you put 45 on the inside.
Anything else? Or is that it? Nolan, louder.
Plus minus.
Yeah, don't forget the plus or minus. Okay? So, listen. Tomorrow is a late start day, right? So you don't have as much time. So, as soon as you get in here, we got to get your quiz to you so you got as much time as you can get to do it.
What's the point of a plus and minus? What's that do?
There's 2 answers. Positive 2i radical 5 works, and negative 2i radical 5 works if I plug it into the original problem.
Thank you. That makes sense.
Okay?
Are the square roots the only problems that we're gonna do?
Yeah, when you square root both sides.